Acceleration and velocity time graphs hide the most lethal examiner trap in the entire physics syllabus. Let us secure your perfect exam grade today. Today, I will decode the exact mathematical formulas and expose the fatal flat line illusion that destroys thousands of students every single year. Imagine a supersonic fighter jet locked into the catapult of a massive aircraft carrier. The pilot hits full afterburner, unleashing pure explosive thrust. The jet violently launches forward, ripping through the air. It travels massively faster and faster with every single fraction of a passing second. Later, the jet lands on the deck. It catches the heavy arresting wire, violently jerking backwards, aggressively slowing down to a complete halt. In strict Cambridge physics, speeding up is positive acceleration. Slowing down is mathematically defined as deceleration, instantly carrying a strict negative value. Acceleration is officially defined as the exact rate of change in velocity. It measures how much an object speed changes every single second. The sacred formula is A equals delta V divided by t. Delta V means the absolute change in velocity. T is exact time. To calculate delta V, take the final velocity, called v, and subtract the initial starting velocity, known mathematically as the letter u. This expands our strict formula to A equals bracket v minus u close bracket, perfectly divided by the total time taken in seconds. Velocity is measured in standard meters per second, but acceleration is strictly measured in meters per second squared. Never forget the vital squared. Let us test this with a high-speed bullet train. It moves at exactly 50 meters per second before the driver hits the brakes. The massive train slows down to 42 meters per second in strictly 30 seconds. Calculate the exact deceleration and prove it mathematically. First, identify the exact variables. The initial velocity u is 50, the final velocity v is 42, the time is 30 seconds. Substitute into the formula. Change in velocity equals 42 minus 50. This yields a highly critical negative 8 meters per second total. Do not drop the negative sign. Divide negative 8 by 30 seconds. The calculator reveals exactly negative 0.27 mathematically. The final answer is strictly negative 0.27 meters per second squared. The negative sign mathematically proves the train is decelerating. Now, we must map this complex motion. We place passing time on the horizontal axis and velocity directly on the vertical y-axis. Because this is a strict velocity-time graph, the visual rules change completely. The steep gradient of the line now perfectly equals exact acceleration. A perfectly straight diagonal line, sloping upwards, proves constant positive acceleration. The object velocity is steadily increasing at a completely uniform mathematical rate. A line sloping aggressively downwards has a negative gradient. This represents constant deceleration. The moving object is steadily losing speed over continuous time. The steeper the visual slope, the massively greater the acceleration. A shallow slope dictates a much smaller, gentler change in overall vehicle speed. This brings us to the deadliest examiner trap on the entire paper. This specific optical illusion destroys more perfect scores than anything else. Look at this perfectly flat, horizontal line on our velocity graph. What is the object doing? Most panicked students instantly write down stationary. The examiner violently stamps a massive red 0 on the paper. The student completely confused a velocity graph with a basic distance graph. On a standard distance graph, a flat line means absolutely stopped. But on a velocity graph, a flat line physically means constant velocity. The speed is not 0, it is simply not changing. If the flat line sits at 10, the object cruises continuously at 10. Because the velocity is perfectly constant, there is 0 change. Therefore, a flat horizontal line mathematically proves the exact acceleration is absolutely 0. Let us master a final multi-stage graph. A professional cyclist moves through 5 distinct physical sections strictly labelled A through to E. Section A is flat exactly at 0. The cyclist is truly stationary. Section B slopes upwards, meaning they are positively accelerating with power. Section C is flat at 5 meters per second. Remember the trap. They are cruising at constant velocity, so exact acceleration is 0. Section D slopes violently upwards, much steeper than Section B. This strictly represents the absolute maximum peak acceleration of the entire cycling journey. Section E flatlines at 10 meters per second. They are heavily cruising at absolute top speed. The mathematical acceleration is exactly 0 again. The strict examiner demands you calculate exact acceleration during Section B between 5 and 10 seconds. We must calculate the pure mathematical gradient. The golden rule is to draw a massive gradient triangle spanning the entire Section B line. Never draw a microscopic tiny triangle here. Delta y is vertical change. Velocity goes from 0 up to 5, so delta y is strictly 5 meters per second in total. Delta x is horizontal time. It starts at 5 seconds and ends at 10. 10 minus 5 strictly equals exactly 5 total seconds. Acceleration equals gradient, which is delta y perfectly divided by delta x. We substitute 5 divided by 5 to get exactly 1 mathematically. The final answer is strictly 1 meter per second squared. Your 3 crucial accuracy marks are mathematically locked and completely secured for good. Protect your exact A-star grade. Subscribe to GetYourTutors.com for the most elite physics masterclasses, completely available anywhere today.